Job sequencing. Job sequencing problem is a classic example of a problem that can be solved by greedy strategy. So let us see what is the job sequencing problem and how are we going to solve this using greedy strategy. First of all, the problem statement is this. You'll be having n jobs and related to each job, you will have a profit and a deadline. And the rule is if you manage to complete this job within the deadline, you will be getting a profit P. And if you don't manage to complete it within the deadline, you will have no benefits at all. So you have to complete it within this deadline if you want to get the profit P that is associated with this job. The other rules are, first rule is that any job will take only 1 unit of time to complete and you can only schedule one job at a time. You can't parallelly schedule multiple jobs at the same time and each of the job will take only 1 unit to complete. So these are the rules. First thing, why are you having to schedule these jobs? Because you will be having limited time slots. So even though you are having a lot of jobs with you, you can't schedule all these jobs within the allotted time. So if you want to schedule within the allotted time, you will have to pick certain jobs from this list so that if you schedule those jobs, your profit will be maximized. So this is the task. Your task is to pick the set of jobs that should be scheduled so that your profit will be maximized. So this is the task you have to do. We already said that we are going to use greedy approach to solve this problem. So what should be the greedy strategy you are using? You know you have to increase the profit. So what should you do? What should be your greedy strategy? You should always try to pick that job which is having maximum profit, right? Whichever is the job with maximum profit, that is what you should always be giving priority to. Because if you can schedule, let us say you have only 4 time slots, you should be choosing those 4 jobs which are having maximum profit. Then only you can gain the maximum out of this. Let us see what are the problems here and what steps should you follow in order to solve this problem. So first of all, we'll consider that we have many jobs, let us say J1, J2, J3, J4, etc. And corresponding to each of the job, you will have a profit associated, let us say P1, P2, P3, etc. And then there will also be certain deadlines associated. D1, what are these deadlines? If you complete within this deadline, you will get complete profit. And if you don't do within this deadline, you won't get any profit. So for each of the job, there will be a profit and a deadline. What is the next thing? The first step you have to do if you want to do job sequencing problem is to sort all the jobs as per the deadline. So you have to sort it, as per the profit. You have to sort these jobs by the profit. Why are you sorting by the profit? You are sorting by the profit because your aim itself is to increase profit. So what should you do? You should have these jobs in the list of decreasing profit. That is, your sorting should be done in descending order. You should sort in descending order of profit. If you sort in descending order of profit, what happens? Whichever is the job with maximum profit will come as number 1 in the list. Whichever is the job having second maximum profit will come as number 2 in the list, and so on. The next step is to create an array of time slots because you want to allot these profits and these jobs which are having certain profits to time slots. So you should create an array and this array should have all the time slot according to the deadlines of these jobs. So you can say the size of this array should be whichever is the maximum value among all these deadlines. So either you can think it that way or you can simply allot an array which is of the size of n. Why am I saying it could be the size of n? Why can't the deadlines go beyond n? The reason is, let us say you have some deadline which is having a value greater than n. Let us say D3 is a value which is greater than n. This is larger than n. Okay. In this case, there is no point in even allotting a slot to D3. The reason is you are having a total of only n jobs. We already said that each job will take maximum of one time slot. This is also clear. If a job will take only maximum of one time slot, and if there is a job which is having deadline more than n, this job can anyway be scheduled, because if you have an array of n, the maximum time slot is of value n. But you are saying your deadline is more than n, which means you can put it in any of these slots. That means whatever be the order you schedule, you can surely accommodate that job which is having a deadline which is more than n. Because of this, all the deadlines of the jobs will either be less than n or equal to n. Otherwise, there is no point in this whole problem at all, right? You can simply schedule all the jobs. The whole problem occurs because you have such timelines which won't allow you to schedule all these jobs, right? That is when the problem occurs. So, all the deadlines will be either equal, less than n or equal to n, because of which your deadline array, your final array of time slots will be at max of the size of n. Okay, so for now, let us say you are having an array of size n. In this, you will be having the final output. Third step is you have these jobs in descending order now. So you have a sorted array here. This sorted array is having jobs in descending order. Okay, these are in descending order of profit. What would you do? You will pick the first job from here, and what is it that you're going to do? You will see what is the deadline of that job. Let us say deadline of this job is 3. Okay, deadline of the job which is having maximum profit is 3. What will you do? You will try to allot it to the slot 3. Why are you allotting it to 3? You could have allotted to 1 and 2 as well, but you will allot it only to the latest possible deadline, because that will give you an option to put the remaining jobs to any of the earlier slots. Let us say you already filled slot number 1 for a job which is having deadline 3. What happens next? If you get the next job which is having, let us say, deadline 1, you won't have any option to allot it at all. But if you allot this job to deadline 3, time slot 3, because it is having a deadline 3, you are leaving first 2 slots free. So later point, if you get a job which is having any of the time slots, let us say time slot is 4, 5, 2, 1, whatever, you can always fit it into the first slot. And if it is having any deadline which is greater than 2, you can always fit it in the second slot. Because of which, you should always try to preserve those slots which are earlier in the array. So whenever you get a job, try to put it in the last possible position. So what should be your strategy here? Greedily, you are picking the job, but once you pick the job, what will you do? You'll try to put it in the last possible option. So last possible option is deadline of the job. You should do it right at the deadline. The same way you submit assignments, you will always try to keep it till the end, and then at the end point when the deadline comes, you will submit it. Similarly, you should try to allot this job to the time slot which is at the deadline. If it is not available, let us say J2, second job, is also having deadline 3. What will you do? You will move towards the left because 3 is already filled. Why not towards the right? Because deadline itself is 3. So there is no point allotting to any slot beyond 3. So you will be moving towards the left and checking for the first available slot. Whichever is the first available slot, you are going to allot this job to that slot. So let us say to slot 2. Likewise, you have to go through each of the jobs in this sorted array and you will try to fill it in the slot. Once you complete filling all of those means filling the time slots. You won't be able to allot all the jobs. Whichever jobs can be allotted into time slot, you will allot them. Once you are done, you will calculate total profit. What is the total profit? Let us say you were able to allot J1, J3 and J4. If this is the case, you will add up the profits of J1, J3, J4. Those profits you will add up, which will be your total profit gained in this job scheduling. So this is the job sequencing problem. Next thing is, we said that whenever you want to do any problem using a greedy strategy, there are two properties that you have to satisfy. So this is important. Whenever you decide or you think a problem can be solved using greedy strategy, you should check for these two properties. If the properties are satisfied, that means you can go forward with the greedy strategy. And if the properties are not satisfied, that means you should ideally not go with greedy strategy and there will be some other strategy which works much better than greedy, right? So what are the two properties? First one is greedy choice property and the second one is optimal substructure property. If these two properties are satisfied, that is when you can make a greedy algorithm. What does the greedy choice property says? It says locally optimal solutions to the problem finally leads to the global optimum in the final global optimum solution. So let us see whether the strategy or the algorithm that we designed for job sequencing, is it following this greedy choice property or not? What is the locally optimal choice that we are making? The locally optimal choice that we are making is that we want to pick that job which is having maximum profit. This is the locally optimal choice. And what happens then? If you choose the job that is having maximum profit, the remaining slots are made available for filling other jobs, and whatever you used is the best usage because this is the, we know every job will take only one time slot. So there is no question of a job taking more time. The only point is which job are you trying to slot it. So here you are using that job which is giving you maximum profit. This is the best choice you can make at this point. And what will be the next choice you make? Next choice you will make will be the job which gives second best profit. After this, you will choose the job which gives you third best profit. So if you go by this way, making locally optimal solutions will finally lead to global optimum solution, because what will be the final set of jobs that you have selected? That will be in the order of maximum profits. So this is why the greedy choice property, that is the property of greedily choosing next options, is followed here. And this property also tells you that if you make the greedy choices, that is the locally optimal choices, you will be finally reaching the global optimum, because of which greedy choice property is followed. Next question is whether the optimal substructure property is followed or not. So according to optimal substructure property, you should be able to break the problem into smaller parts. And once you break into smaller parts, finding the optimal solution for these smaller pieces should finally give you the final solution. This is optimal substructure property. So if you look into the present thing, when you schedule one job, it is not interfering with the scheduling of other jobs. That is provided deadlines are respected, and it gives you that modularity which is allowing you to solve smaller instances of the problem. That is, let us say you have one job J1. If you initially, what was the problem? You have a lot of time slots and you want to allot the jobs into this time slot. Let us say you allotted one job J1 into some time slot. After this, you are actually making the problem into a smaller sub-problem of itself, which says you have to schedule remaining jobs. Initially, your problem was that you have to schedule all the jobs into these time slots. Now that one time slot is already used, your new problem is you have to schedule the remaining jobs in the remaining time slots. So what did you do? You made the problem into a smaller problem of the same kind. So there is optimal substructure here. You are able to divide this problem into smaller problems and solve each of the smaller problems separately, because of which optimal substructure property is also followed, which means both greedy choice property as well as optimal substructure property are followed, and you can use the greedy strategy for solving this problem. Lastly, let us see two more things. One is the time complexity of this problem, and the other thing is we need to see an example so that we understand very clearly how the job sequencing is working here. So first let us clarify on time complexity. Here you are sorting all the jobs in descending order. So it will take order of n log n time complexity. What is the next step? You are simply forming an array. So this you can leave maximum order of n. And what about the last third step? In this step, you are picking each job one by one from the sorted array. So that will be order of n for picking. And once you pick inside this, what are you doing? Once you pick it, you are going to check for the slot which is available. And what is the worst case scenario? Let us say your deadline is last block, that is 5. That is, here it is 5, whatever be your last block, let us say n. From that nth slot, you will be checking each slot towards the right to see which is the first available slot. And in the worst case, you may have to check through all the slots available till you reach the first slot. So in worst case, you may have to make order of n moves in this single step. So there are order of n steps, there are order of n jobs available, and for each job you may have to make order of n moves, which means the total time complexity is order of n into order of n, which is order of n square. So worst case time complexity of this is order of n square. See, you may also see somewhere that it is order of n into d. The reason is if d is the maximum timeline that you have, time slot that you have, I mean the deadline that you have, in that case, total size of this array will be d. So for each of the n steps, you will be making a maximum of d searches. So it will be order of n into d. So here we are considering that d is of the order of n because you have deadlines which should be of the order of n. So because of that, we are considering order of n square. Okay. So time complexity of this problem is order of n square. And what about this is the time complexity. What about the space complexity? Space you're consuming is for this particular array, which is having time slots, and this is where you are inserting all the jobs. So for this array, what should be the space required? Again, it is order of d, where d is the maximum deadline that you have. So we are considering d to be of the order of n. So you can say order of n is the time complexity of this algorithm. So a space complexity of this algorithm. So time complexity is order of n square and space complexity is order of n. So before we conclude this lecture, we'll take an example and try to understand exactly how this job sequencing works. Let us say your jobs are J1, J2, J3, J4 and J5. These are the jobs that you have. Let us say corresponding to these jobs, you have profits. J1, let us say it is having a profit of 10. J2 is having a profit of 50. J3 is having, let us say, 30. This is having 20 and J5 is having 40. These are the profits. And what about the deadlines? There are 5 jobs and my deadline, let us say for J1 is 3, J2 is 2, J3 is 3, J4 is also 3 and J5 let it be 4. So these are the deadlines that I have. How do I solve it? I'll first sort it in the descending order of profits. So once I sort it in the descending order of profits, what will be the order of jobs available? The maximum profit is available for the second job. Profit is 50. So J2 will come first. What will come next? Second best profit is for J5, which is having profit of 40. So J5 will come second. Third best profit is a profit of 30 on J3. So J3 will come number 3. What is the next best profit? For J4, profit is 20. So J4 will come next. And J1 has a profit of only 10, which is the last in a descending order sorted list. So this sorting is according to the profit of these jobs. What is the next thing? Next thing is we have to start an array. So this array can be the size of order of n. So let us say I have first time slot, second time slot, third time slot, fourth time slot and fifth time slot. So I have a total of 5 jobs. Ideally, I need only an array of size 4 because my maximum deadline is 4. I'm still taking 5. The fifth slot will anyway not be used here. What is the last and third and the last step? I'll be picking the jobs from this sorted list and I'll be allotting it into the slots. So let us try this. First pick will be J2. I'm going to pick J2. What is the profit J2 will give me? J2 will give me a profit of 50. And if I want to get this profit of 50, I have to complete it within the deadline of 2. 2 is the deadline for J2. So I'll check the last possible slot, that is 2. Second slot is available. So I'll put J2 into the second slot. So what is my total profit now? Total profit till this point is 50 and complete profit came from J2. So I'm going to select the next one. Next is J5. What is the profit of J5? J5 is having a profit of 40. 40 is the profit. And if I want to get that profit, I have to complete within the deadline 4. So 4 is the deadline. I'll check the slot 4. It is empty, which means I can put J5 into slot 4. So my profit now is 50 plus 40, which is 90. So my total profit now is 90. Which is the next job? It is J3. J3 is having a profit of 30 and the deadline of J3 is 3. 3 is the deadline. So I'll try if 3 is available. Yes, 3 is available. So I can put J3 into the third slot and my profit will become 90 plus 30, which is 120. So 120 is my total profit now. I already allotted 3 jobs. Which is the next job in the sorted list? It is J4. What about J4? J4 is also having a profit of 3. Deadline of 3. And profit is 20. What about the deadline? Deadline is 3. I'll check whether slot 3 is available. 3 is not available. So I'll move one step towards the left. I'll check whether slot 2 is available. It is also not available. What is the next step? I'll again move towards the left. Slot 1 is available, which means I can put J4 into slot 1. So I got 20 more as profit. So my total profit is 140 now. 140 is my total profit. Which is the next job available? It is J1. J1 is having a profit of 10 and its deadline is 3. If the deadline is 3, I should start checking from 3 because there is no point in inserting in 4 or 5 because that is after the deadline and I won't get any profit there. In 3, it is already occupied. I'll move towards the left. 2 is also already occupied. I'll again move towards the left. 1 is also occupied, which means there are no available slots where I can put J1, because of which J1 cannot be scheduled here. So in order to make maximum profit, the jobs that are picked to be scheduling are J4, J2, J3 and J5. So I won't be able to schedule J1. What is the total profit? It is 140. So this is the profit we made from greedy strategy. You can try out with whatever strategy you have. You will never be able to make a profit which is more than 140. That is why this is applicable for greedy strategy.